So let's go ahead and get started with chapter 2.
Yeah, we did this. I remember this.
Okay. So we're going to start with what we call synthetic division. So synthetic division is basically a shortcut way to divide polynomials. So this is polynomials. And we're only going to use it if we're dividing by a linear factor, right? Dividing by a linear factor. Linear means the highest exponent is a 1. So let's take a look at part A. So this says determine for which of the following cases synthetic division can be used. So can we use it for this first one? No. Look at the denominator. It's not a linear factor, so no.
I don't get what it means by using linear.
So what does linear mean? When the highest exponent is a what?
It's 1.
1. So here you have an exponent of 2, so that's not a linear function. Well, what about B? Does that work? Is the denominator, is it being divided by a linear factor?
Yes.
Yes, so this works. Here, dividing by this one, linear or no?
No.
No. Here, this one is linear, so yes. Okay? All right. So let's see how we're going to divide. So we're going to divide x cubed minus 3, this polynomial, by x plus 1. Okay, so first you have to set up the synthetic division. You have to make sure that in the polynomial here, all of the exponents are present and they are in descending order. So the highest exponent here is 3. And then see if all the other exponents are there. So power of 3, 2, 1, 0. Yes, they're in decreasing order, so we're good. Next. What you have to do now is you have to put all of these coefficients into this chart. So the first coefficient here is a what?
1.
1. The next one is negative 3, negative 2, 4. Now what goes on the outside? You get this x plus 1, you take the x plus 1, you set it equal to 0, and you solve for x. So x is negative 1, that's what goes over here. So, step 2. Bring down the leading coefficient to the bottom row. The leading coefficient is this one. It just comes down to the bottom row for free. Then multiply the value just written on the bottom row by the outside number. So whatever makes its way to the bottom gets multiplied by the red number outside. So negative 1. Now you add this and you get negative 4. And then the process repeats. Whatever makes it down to the bottom gets multiplied by negative 1. You add, you get 3. Multiply by negative.
Would it be negative 6? No. It would be negative.
Oh, this is negative 4. Sorry. So this would be.
Positive 4.
Sorry. So this would be 2. And then negative 2 and 2. Okay? And now you have to write out the answer. So basically, this last number is called the remainder. Okay? Yeah.
Oh, wait, never mind.
Okay? So that's called the remainder. And now here's how you write out the answer. The initial function had a higher exponent of 3, correct? when you do synthetic division, the exponent gets reduced by 1. So instead of x cubed, now it's x squared. And these happen to be the coefficients of the new function. So now the new function is gonna start with x squared. So look up here, it's gonna be this 1x squared minus 4x plus 2. You see that?
Can you just write
so it's gonna, okay, so yes, so it's gonna be x squared minus 4x plus 2 plus the remainder over x plus 1 from above. Okay? So
that's the answer?
That's the answer. So now let's do another one. Here. Take a look at this one. I have to divide these two. So remember the first step was make sure all the exponents are there and in the right order. So here I have an exponent of 4, 3. I'm missing a 2. So I have to place a 0 as a placeholder. Then I have 1 and 0. So let's go ahead and do that and I'll get your question in a minute. So I have...
It doesn't have to be a polynomial though? Or it has to be linear? Because it's not,
no.
It's not 1.
Okay, hang on. Let me do this before I lose track. So 1, 4, 0, negative 12, negative 9. Okay, the thing that has to be linear is this x plus 3.
Yeah, but it's not linear.
It is linear.
That has to be 1.
The x has to have an exponent of 1. So x plus 3 equals 0. X is negative 3. So negative 3 comes out here. Okay, so 1 moves down. Multiply, you get negative 3. Add, you get 1. Negative 3. Add, you get negative 3. Multiply, you get 9. Add, you get negative 3 again. Multiply, you get 9. Add, you get 0 for the remainder. Perfect. So now, originally, my highest exponent was a what? 4. Now it's going to be a 3. So it's going to be x cubed plus x squared minus 3x minus 3. Okay, that's it. No remainder. That's it. Okay, so do you see the coefficients, right? 1, 1, negative 3, negative 3. Okay? All right.
Why is it the x cubed?
Because we started off with x to the 4, and the process of dividing synthetic division reduces the exponent by 1.
Oh,
okay. Next we have another exception to the rule, or another special case. We have this divided by 2x minus 3. Now this is okay. This is a linear function. 2x to the 1. This is linear, so we're good. The issue, though, is the coefficient is not a 1. Okay? It's 2x instead of 1x. So, this is important. You have to divide both polynomials by 2. Okay? You have to divide both polynomials by 2. So I'm going to divide all of this by 2 and all of this by 2. The biggest pitfall for students is they do this step in their head and they don't take the extra time to rewrite things. Please don't take out your calculators. We're not going to do this with a calculator. So here's what we're going to do. Divide each of those numbers by 2. So I'm going to get 1x cubed minus 3 over 2x squared minus 1x plus 3 over 2 divided by x minus 3 over 2. The stuff before has now disappeared. This is all we're going to work with now. All right? So, let's do it. Let's look at the exponents. I have an exponent of 3, 2, 1, 0. We're good. Let's do it. Okay. My coefficients are 1, negative 3 over 2, negative 1, 3 over 2. What goes outside?
3 over 2.
Is that right?
Negative 3 over 2.
Positive 3 over 2.
Why positive?
Because you set it equal to 0 and solve.
Oh, yeah.
Okay, so 1 comes down. Multiply by 3 over 2, you get 3 over 2. When you add these, what do you get?
0.
Multiply by that, you get 0. Negative 1. Negative 3 over 2. When you add, what do you get? 0. Remainder is 0.
You get 0.
So exciting. Okay, hang on. Okay, we're not going to freak out. Okay? Because we've got an extra 0, because we've got a 0 in the middle there. What was the highest exponent before? Cubed. What is it now? Squared. So, it's going to be 1x squared plus 0x, which we don't have to write it, but I'm just writing it right now, minus 1. Okay, but what the heck is x squared plus 0x? That's not a thing. So this is just going to be x squared minus 1. Okay? Okay, so let's talk about, okay, so that's one thing. I just did that to get it out of the way. So now we can do now we can see where this is used. Okay, so remember when you were taking algebra and you talked about zeros of a function, you learned that a 0 of a polynomial function is the x values where the graph crosses the x-axis. Okay? A 0 is one name for it. So for example, if I have a function like this, all of these points are the zeros. A 0 is one name for it, but it could also be called a solution, a root, or an x-intercept. Exciting stuff. Okay, so how do we evaluate a function at a given point? So for example, if I gave you f of x is blah, blah, blah. Now I said find f of 2. Well, there are two methods to find the value of a function. They are called direct substitution and synthetic substitution. Okay? You know direct substitution. You've been doing it all your life. Okay? So take a look here. You have f of x is blah, 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 blah. Find f of 2. What do? Plug 2 into all of the x's. So 2 times 2 squared plus 9 times 2 minus 35. This is 2 times 4, 8 plus 18 minus 35. How much is that? 26 minus 35. Is that 11? We'll pretend it's 11. Is it 11? What do you think, Cooper?
Yes.
Okay.
Approximately.
Oh no, it's negative 11.
Okay, I was gonna say that.
Isn't it?
Yeah, because it's 25 minus. Yeah.
No, it's 26 minus
26. I misspoke.
Huh?
Me and Cooper were discussing previously this class that we should test you all, and that's what just happened.
No, it's negative
since
9.
we had the answer.
Oh, it's negative
It's
9.
negative 9.
That's what I thought.
You guys are wrong.
You guys are so wrong.
You guys are stupid.
Oh,
That's me.
So 2 times 49. How much is that?
That's like 98.
We're not going to guess this one.
Around that.
Plug it in. Go.
Square.
So I squared in my mind. So 7 squared, I got 49.
It's 98.
Oh.
Is it 98?
Yeah. Yeah.
Are any of these zeros of the function?
They are zeros
Are they?
because that's the x. So you're given the x and y.
Well, right, but are they zero? What were zeros? Zeros
it
were
says
where?
x equals 0, so none of those are not zero.
So let's see. So it says f of 2 is negative 9. F of negative 7.
She just didn't finish.
So this is 0. So now, are any of these zeros? So what is,
98?
okay, no.
No, it's 0.
So what is this telling you? F of 2 is negative 9. When x is 2, the y value of this function is negative 9. When x is negative 7, the y value is 0. So are any of these zeros?
Yeah.
Which one?
-7.
The negative 7 is a 0.
Wait, how?
Because a 0 is where a 0 is where the graph crosses the x-axis. So here,
Anytime f of x is 0.
right. So here, what are the y values there? 0, 0, 0. So whenever for the y value you get a 0, that's a 0 of the function. Negative 7 is a 0. So x equals negative 7 is a 0 because f of negative 7 equals 0. Huh?
Just scroll up, I can see it.
Huh?
I want to write it down.
Okay, now, yeah,
So, what does this have to do with like what we were doing before?
okay,
It will in a second.
it's coming. Okay, another way to get these values, okay, another way to find f of 2 and f of negative 7 is to do synthetic substitution, okay? This one uses synthetic division to evaluate the function at a given point. So, f of 2, instead of plugging it in and doing that fiasco with the guessing and the being wrong and the whatever, we're going to do another method. We're going to do synthetic division. 2, 9, negative 35, okay? These values, coefficients. Here, you put this number as is. Don't change the sign. Okay? So, 2 comes down. Multiply by the outside 2. Add. Multiply. Negative 9. That is your answer. So, f of 2 equals negative 9. Now let's do negative 7.
So remainder of the
Right, let's do negative 7. 2, 9, negative 35, 2, negative 14. How much is that?
5.
5, negative 5. Multiply, you get positive 35. You add, you get 0. So f of negative 7 is 0. You can. This is the point. Now there are two ways. Until now, you always did that way. But now this is another way, and it's a much more preferable way, trust me, when the numbers get bigger. So how can we tell if any of these are 0 when the what is 0?
When the f of something is 0.
In here. When the remainder is 0. Nice. Okay. So, let's talk about the rational zero theorem. The rational zero theorem gives us a way, okay? The rational zero theorem gives us a way to get a list of candidates that could be rational zeros of a function. So what does that mean, rational zeros? Okay, a function can have any zeros, right? So for example, take a look at this function here. Take a look at this function. When you solve it, the place where it crosses the x-axis are -3 and 2/3. Both of those are rational numbers. Rational numbers are numbers that you can write as simple fractions, okay? Look at this function. The place where this crosses the x-axis, its zeros, are √5 and -√5. Those are irrational zeros, irrational numbers, okay? So there is a way that you can get a list of candidates from where you can pick rational zeros. Here's how we do this, okay? It's called the rational zero theorem. Okay. Basically, what you have to do is you have to find values of P and Q. Okay? Now, where do these numbers come from? Don't read ahead. Listen to what I'm saying. Where do these numbers come from? To find the values of P, find all the factors of the last term 4. Okay, so what are the factors of 4? Basically, what numbers multiply to 4? Well, 1 and 4, 2 and 2, right? But how about -2 times -2? Isn't that also 4?
Yes.
Yeah.
So the factors are not just 2, but also -2. Not just 1, but also -1. That's why we write them as ±1, ±2, ±4. Those are all the factors of 4. Next, for Q, so this gives you the values for P. For Q, we go to that coefficient. And we find the factors of 2. Well, what are the factors of 2? 1 times 2, or -1 times -2. So ±1, ±2. Now, here's the good part. We have to divide each of the values of P by the values of Q. So this 1 divided by 1 and 2, 2 divided by 1 and 2, 4 divided by 1 and 2. Okay? So here's what you get. You do 1 divided by both of these. So that's going to be ±1 ±1/2. You guys okay with that? So the top number, the 1, divided by the 1, you get 1. Then divided by the 2. Next, this one. Divide by this and by this. So 2 divided by 1, you get what? 2. 2 divided by 2, what do you get? 1. Okay? 2 divided by 2, you're going to get 1. Now, have I already written 1 here?
Yeah.
Okay, don't write it again. Okay? Next, I'm going to do this one, the 4. I'm going to divide it by the 1. What do I get? 4. Divided by the 2, what do you get?
2.
Do I already have a 2?
Yeah.
Don't write it again. Okay? So now, these numbers form a list of all possible rational zeros. Okay? So, if that function at the top crossed the x-axis at some rational number, it's got to be either 1, -1, half, -half, 2, 4, and so on. Okay? All right, so let's move on. Oh, we're not going to move on. That's where we're going to end today. Okay? All right.